Every wireless technology around us depends on a single physical phenomenon. Wi-Fi, Bluetooth, GPS, cellular networks, satellite communications, and radio broadcasting all work because energy can travel through space without wires. That phenomenon is called electromagnetism, and it forms the foundation of all RF engineering. For most of human history, communication required a physical connection. Information traveled through spoken words, written messages, or electrical wires. Yet today, enormous amounts of information move instantly through empty space. Phones connect to cellular networks, satellites communicate across thousands of kilometers, and Wi-Fi routers send data throughout buildings without any visible connection. This raises an important question. How can energy and information travel through space when there is no physical wire connecting the transmitter and receiver? What mechanism allows wireless communication to exist in the first place? To answer this question, engineers must understand electromagnetism. It is the branch of physics that explains how electric and magnetic fields interact and how electromagnetic waves carry energy and information through space. Electromagnetism is the study of electric charges, electric fields, magnetic fields, and their interactions. It describes one of the four fundamental forces of nature and governs the behavior of electricity, magnetism, and electromagnetic waves. An electric charge creates an electric field around itself. When charges move, they generate magnetic fields. These electric and magnetic fields are not separate phenomena, but are deeply connected. Changes in one field can create changes in the other. This relationship leads to one of the most important discoveries in physics. A changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. Together, they can sustain each other and travel through space as an electromagnetic wave. Intuitively, electromagnetism can be viewed as a mechanism for transferring energy through invisible fields. Just as waves can travel across the surface of water, electromagnetic disturbances can travel through space, carrying energy and information. Physically, consider a radio transmitter. Inside the transmitter, electrical currents rapidly oscillate back and forth. These changing currents create changing electric and magnetic fields. The fields detach from the antenna and propagate outward as electromagnetic waves that can travel vast distances. Mathematically, electromagnetism is described by Maxwell's equations, which connect electric fields, magnetic fields, charges, and currents. These equations predict the existence of electromagnetic waves and explain many phenomena observed in RF engineering, communications, and modern electronics. Electromagnetism is the fundamental science behind every RF system. Whenever an antenna transmits a signal, electromagnetic fields are generated and launched into space. When another antenna receives that signal, it converts the incoming electromagnetic energy back into electrical form. Wireless communication systems such as Wi-Fi, LTE, 5G, Bluetooth, satellite communications, radar systems, and GPS all rely on electromagnetic wave propagation. Without electromagnetism, wireless technology simply would not exist. At the system level, understanding electromagnetic behavior allows engineers to design antennas, transmission lines, microwave circuits, waveguides, and communication links. Nearly every advanced RF concept is built upon electromagnetic principles. Electromagnetism is unique because it connects physics directly to engineering. It explains how energy moves through space, how antennas radiate signals, how communication links operate, and how wireless networks function in the real world. A common mistake is thinking that radio signals are somehow different from light. In reality, radio waves, microwaves, infrared light, visible light, ultraviolet radiation, and X-rays are all forms of electromagnetic waves. The primary difference is their frequency. This lesson serves as the starting point for the entire electromagnetic journey. Before studying wave propagation and antenna systems, we must first understand the fundamental building blocks of electromagnetism. The first of these building blocks is the electric field. In this lesson, we learnt that electromagnetism is the branch of physics that explains the relationship between electric fields, magnetic fields, and electromagnetic waves. We also saw how electromagnetism provides the physical foundation for wireless communication, RF engineering, radar systems, and modern communication networks. In the next lesson, we will explore the electric field and discover how electric charges create forces and influence the space around them. If you found this useful, like the video, subscribe, and follow for the next lesson.